Hello, today we are looking at 9.1, inverse and joint variation. Before we jump into our new material, I want to quickly review direct variation, which we learned earlier this year. So direct variation is if y equals k times x, where x is not equal to 0, then y varies, and it's read as y varies directly with x. And this was one of those topics that's super simple, but the wording of it makes it more complicated. All direct variation is a linear equation that starts at 0, 0. And they make things more complicated. So we all know y equals mx plus b. Because we're starting at 0, 0, there is no plus b. And instead of being easy about it, they simply take the m out and replace it with k. But k is still your constant, and your constant rate of change is your m, or your slope. So direct variation, just a linear equation that starts at 0, 0. When we move on to our new equation, that's inverse variation. And you can see that the equations are very similar. Direct is y equals k times x, and inverse is y equals k divided by x. Again, k can't be 0. K is still representing that constant of variation. And this is read that y varies inversely with x. So if it's direct variation, we're multiplying by x, and if it's inverse variation, we are dividing by x. So we want to classify the following three equations as direct or inverse variation. And the easiest way to see this relationship is to solve for y. So in our first one, we've got y divided by 5. To move the 5, the opposite of dividing is multiplying. So we've got y is equal to 5x. So you think to yourself, is this direct or inverse? If it's direct, we're multiplying by x, and if it's inverse, we're dividing by x. So this one is pretty easy. We can see that it's direct variation. We move on to number 2. We've got x plus y is equal to 5. Again, if we want to solve for y, to move x, since we're adding x, is to subtract x. So we've got y is equal to 5 minus x. Is this direct or inverse? This is actually neither. This is none. If it was direct variation, we'd be multiplying our constant by x, which we are, and that constant would be a negative 1, but the only difference is in direct variation we start at 0, 0. Here our starting point would be at 5. So this linear equation, y equals a negative x plus 5, would start at 5, and your slope would be a negative 1. Direct always starts at 0, 0. And our last one, we've got x times y. So to move the x, we divide both sides by x. And we've got y is equal to 5 divided by x. And we can see that that is an inverse variation. Alright, now that we have identified an inverse relationship versus a direct variation, let's talk about how to write an inverse variation equation. So we want to write the inverse variation equation. The variables x and y vary inversely. Y equals 8, x equals 3. Write the equation. Remember, paying attention to what you're trying to find that relates x and y. Well, we know that our inverse is y equals k over x. We are told that y is 8. We're told that x is 3. So if I want to solve for k, I'm dividing by 3, so I multiply by 3 on both sides. We've got that k is 24. We can't stop there because it says to write the equation. So we plug in our 24 for k, and we get y equals 24 over x. Remember, anytime you're writing the equation, you should have your y and your x in the equation. So we're replacing the 24, and we're keeping the x and y. So now we want to find y when x is equal to a negative 4. So we have the equation that we found in part A. We want to find what y is when x is -4. All we do is plug that in. 24 divided by a -4, we've got y is equal to a -6. So for part A, writing the equation, you have to find that constant, that k value. Once you find the k value, you plug it back into the general form. Use that new equation that you found to find your missing variable. Alright, so let's flip on over to the back page. Trying to determine if it's direct, inverse, or none given a table of values. So we know how to do it given an equation. Now let's look at tables. We look at our x values. We're going 5, 4, 3. Our x values are going down. We look at the y values. 20, 16, 12. They are going down. If both the x and y are going in the same direction, the only possibility it could be is direct variation. So we're trying to ask ourselves, is it direct variation? Direct variation means that if one's going up, the other one's going up. If one's going down, the other one's going down. It has that constant relationship. So if they're either both pointing down or they're both pointing up for direct variation. If it's direct variation, we've got y equals k times x. What we want to do is see if this is true for our points. So we go to our table, we take out a point. Our y is 20, our x is 5, we find that our k is 4. We divided both sides by 5. We pick another point. We've got our y is 16, our x is 4. We divide by 4, we find that k is equal to 4. Since we have the same k of constant variation, that is telling us that this is going to be direct. We check to see, is it direct? Both the k values were the same, therefore it is. When we go to our next one, we've got 1, 2, 4. Our x values are going up. We've got our y's, 20, 10, 5. Our y values are going down. If one is going up and the other one's going down, we're going to check, is this inverse? Is it an inverse relationship? If it is, it would follow the pattern of y equals k over x. So again, we check some points. Our y is 20, our x is 1. So we found here that k is equal to 20. We check our next point. We've got 10 is equal to k over our x of 2. We find that k is 20. Since both of our constants were the same, this is going to be inverse. And our last one, we've got 2, 6, 4. Alright, so our x value went up and then it went down. What that means is we need to rearrange. It should always be going in the same direction. If it's going up, it should be going up the whole time. If it's going down, it should be going down the whole time. So I'm going to take this point and move it here. So now we've got 4 and 15. So that's been moved to the correct spot. So we went 2, 4, 6. Our x values are going up. We've got 10, 15, 20. Our y values are going up. Since the x's and the y's are both going in the same direction, we're going to ask ourselves, is this a direct variation? If it is, it's going to follow that pattern of y equals k times x. We take a point 2 and 10. So we've got 10 is equal to k times 2, divide by 2, and we've got k is equal to 5. You can take any point you want. Let's do the 4 and 15. So we've got 15 is equal to k times 4. K equals 15 over 4. Those are not the same, therefore this is none of them. It's not direct nor inverse. So as a recap for tables, you first look to see where the values are going. Are they going up or are they going down? If your arrows are pointing in the same direction, so if they're both going up or they're both going down, you're going to see if it's a direct relationship by seeing if two of your points have the same constant. If one is going up and one is going down, the only thing it could be would be an inverse relationship since they're not going in the same direction. Again, you check for the same k, the same constant. If they have the same constant, then it is inverse. If your table is not in order, which means if it's not always going up or always going down, it doesn't matter if it's going up or down, but it does have to be constant, you have to rearrange them. Once you rearrange them again, both of our errors were going up, which means we were checking for that direct relationship. Since we did not have the same constant for all of our points, it was not direct, and therefore it was nothing because it couldn't have been inverse. Inverse would have different directions. Alright, almost done. We've got one more topic, and our next topic is joint variation. So we've got if z is equal to k times x times y, k cannot be 0. Again, our constant can't be 0, and this is read as z varies jointly with x and y. So we've got the variable z varies jointly with x and y, and x is a negative 12, y is 4, and z is 2. So we're going to jump right into writing the equation. So we know that we always start with the general, z equals k times x times y. And we always start by finding that k value, that constant. Well, we're told x is a negative 12, y is 4, and z is 2. So we've got k times a negative 48. We divide by a negative 48. And we've got k is equal to a negative 1 over 24. If I had asked for the k value, the constant, I would be done, but I'm asking for the equation. So we plug that into the general form. So we've got z is equal to a negative 1 over 24 times x times y. Hopefully you've noticed that joint variation is very, very similar to that direct variation, but instead of just multiplying by x, we're multiplying by x and y. So what we want to do is we want to find z when x is a negative 4 and y is equal to 7. Well, we have our equation. We're going to plug in for our x and for our y. So we've got a negative 1 over 24 times a negative 4 times a positive 7. The negative times the negative becomes positive, and z is equal to a positive 7 over 6. Your 4 and 24 cancel, and that will be your z value. So we've got direct, we've got inverse, and we've got joint. Direct, you're multiplying. Inverse, you're dividing. Joint, you're multiplying by more than one piece. K is always going to be your constant, and K is always going to be on top. What's going to change is the location of your variables. So we're going to write all the different kinds of variation that we talked about today. So our first one, y varies directly with z. For each of these, what I want you to do is take a quick second, pause it, see if you're right, and then go ahead and check. So for number 1 again, y varies directly with z. If it's varying directly, we've got y equals k times z. Directly means we're multiplying by z. For number 2, k varies inversely with y. X varies inversely with y. Remember, pause, write your equation, and then check. So since it's x varies, that means it's x equals inversely with y means y is on the bottom. K is always on top. Number 3, z varies jointly with m squared and n. Go ahead and pause and write. Since z is varying jointly, that means z varies, z equals. Jointly with m squared and n means that we're multiplying by m squared and by n. Alright, our last one, y varies directly with x squared and inversely with z. Go ahead and pause. Y varies means y equals. Directly with x squared, remember k is always going to be on top. If it's directly with x squared, that means we're multiplying by x squared. If it's inversely with z, we are dividing by z. K is always in the same spot. Whether it's direct, we multiply, so it stays on top with the k. Inverse, we're dividing, it goes on the bottom. Joint means there's more than one piece on top. Alright, and we are now finished for today.